The purpose of today's lesson is to be able to solve proportions, and sometimes we're going to get quadratics when we solve these proportions. But in this warm-up, we have a couple questions where it's just simple proportions where we can cross multiply. So we'll take x times 5 in the first example, and we get 5x equals 2 times 9 is 18. We want to get x by itself, so we divide by 5, and we get x equals 18 divided by 5. In the second example, when we cross multiply, the 10 times 9 becomes 90, and then in the second part, we're going to take 6 times the whole thing x plus 2, which ends up being 6x plus 12 equals 90. Now our goal is to get x by itself, and there's only one x, so we can subtract the 12. We get 6x equals 78, and then we want to divide by 6. So we get x equals 78 divided by 6 is 13. There's one answer, and we can always check these answers to make sure they're right. So we could plug in 13 and get 13 plus 2 is 15. 15 divided by 10 is 3 halves, and 9 divided by 6 is 3 halves. So it does work because we get a true statement there. Here, we're going to plug in, when we cross multiply, we get m times 1, which is just m, and then 3 times the whole thing, m plus 1. So we distribute, so we get m equals 3m plus 3. And then we want to go ahead and get m by itself. In this case, we're going to go ahead and subtract the 3m, get negative 2m equals 3. We're still trying to get m by itself, so we get m equals negative 3 over 2. All right, so here we have another answer that we can plug in, negative 3 halves. Negative 3 halves plus 1 gives us negative 1 half, divided by negative 3 halves. Does that equal 1/3? Well, when we have a complex fraction, we multiply by the reciprocal. So we multiply by 2 over negative 3 on the bottom and 2 over negative 3 on the bottom, or top. And this cancels, so we get positive 1/3 equals 1/3. So again, it creates a true statement, so we know that this is the correct answer for that proportion. In these following examples, when we cross multiply, we just don't get a linear problem anymore. We end up getting an x squared problem. So we're going to take x times x minus 9. Now you multiply the whole thing equals negative 14. Now when we multiply, we have to distribute the x, and we get x squared minus 9x equals negative 14. This creates a quadratic. Whenever we solve a quadratic, we like to set it equal to 0 and then solve it. So we're going to add the 14. We get x squared minus 9x plus 14 equals 0. There's many ways to solve a quadratic. We can try factoring if that works. That's probably the quickest. The square root method if it's a binomial with no linear term, and then a quadratic formula. In this case, we want to ask ourselves what two numbers multiply to give us 14 and add to give us negative 9. We do have two numbers, negative 7 and negative 2. Because the leading coefficient is 1, we can just jump to our two factors. And now we set each one equal to 0. So we set x minus 7 equal to 0 and x minus 2 equal to 0. We end up getting two different answers that could potentially work. X equals 7 and x equals 2. We need to be cautious when we're working with proportions, because the one thing we know is the denominator cannot equal 0. So we're going to plug in 7 and 2 to see if they work. When we plug in 7 for x, we get 7 divided by 7 is 1. And when we plug in 7 over here, we get 7 minus 9 is negative 2, and negative 2 divided by negative 2 is 1. So 7 works. Now we're going to try 1. Or, the other answer was 2. We're going to try 2 as our other answer. So when we plug in 2, 2 divided by 7 is 2/7. And when we plug in 2 here, we get negative 2, and 2 minus 9 is negative 7. we get negative 2 over negative 7, which gives us 2 over 7. So that is true. So in this case, both solutions work. Taking a look at number 5. In number 5, we know that if we get 0 as a solution, it's going to be called an extraneous solution or a fake solution, because we can never divide by 0. So if our answer turns out to be 0, we know that's a fake solution. In number 5, we're going to go ahead and cross multiply. We're going to take the quantity v minus the square root of 30 times v plus the square root of 30. Now these have a very special relationship. They're called conjugate pairs, because the only thing that's different is the plus and minus sign in the middle. Conjugate pairs have a special relationship when we multiply, and we'll see that in just a second. V times negative 11 gives us a negative 11v. So now we're going to go ahead and multiply. V times v is v squared. V times the positive square root of 30 is plus square root of 30, v. Then negative square root of 30 times v is negative square root of 30 times v. And if we have the square root of 30 times the square root of 30, we just get 30. But in this case, it's negative square root of 30 times a positive, so we get negative 30 equals negative 11v. All right. In this situation, the positive square root of 30 and the negative square root of 30 end up canceling each other out. When they cancel each other out, they give themselves 0. All right, so when we simplify, we have v squared minus 30 equals negative 11v. Again, we're left with a quadratic, so that means we want to go ahead and get this equal to 0. We're going to add 11v to both sides. So we have v squared plus 11v minus 30 equals 0. So we ask ourselves, what two numbers multiply to give us negative 30 and add to give us 11? It would be nice if 6 and 5 could work, but they either have to be one positive, one negative, because we've got a negative 30 here, and that won't give us positive 11. We can try 2 and 15, but that's not going to give us 11. We could try 3 and 10, but that's not going to give us 11. So in this case, we can't factor. If you can't factor, then we're going to go ahead and do the quadratic formula. The quadratic formula, every time we use it, let's write it out. X equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. We plug in our values. We get x equals, our b is 11, so we have negative 11 plus or minus the square root of b squared, which is 121, minus 4 times 1 times negative 30, all divided by 2 times 1. So we multiply negative 4 times negative 30, which gives us a positive. So we're going to have 121 plus 120. So we get x equals negative 11 plus or minus the square root of 241, all divided by 2. We see if we can simplify 241. In other words, are there any perfect square factors in 241? And there's not. So this is our exact answer. We could convert this to a decimal, but we don't need to. So we're good with this one here. And the directions say no calculator, so that's a clue. Without a calculator, we can't do this. So that's a clue that we can leave this in simplified radical form. All right, at this time, there's this question 6 here. I'm going to go ahead and pause the video, take a minute, work through number 6, and then unpause the video when you're done to check your answer. So at this time, you've finished number 6, and when we work with number 6, it turns out that this quadratic we can factor, so we get two different answers. You can state your answers as x equals negative 4 or x equals negative 2, or you can put it in set notation but the squiggly bracket -4, comma, -2. Either way is fine. Now we do want to check these answers to make sure that we don't have an extraneous or false solution. If we plug in -4, the denominator is not going to equal 0, so that's okay. If we plug in -2, the denominator is not going to equal 0, so it's going to be okay. And when we plug those two in, we end up getting a true statement both times. So let's take a look at this one, number 8. Number 8 is a unique situation because when we cross multiply, we could multiply this out and get a cubic and then factor the cubic, which we want to try and avoid that. So there's two ways to approach this problem. If we cross multiply, let's not multiply it out. Instead, let's get x squared minus 16 times 4x plus 3. We're not going to multiply it out quite yet. And then we have 41x minus 12. We're not going to multiply it out yet. And then x minus 4. Now looking at both sides, we can see that an x minus 4 is going to appear in both sides. So if we factor this, instead of multiplying it, we're going to factor it. And we get x minus 4, x plus 4 times 4x plus 3 equals, and then we're not going to multiply this out, instead we're going to keep it factored, 41x minus 12 times x minus 4. We can divide by the common factor. We don't like to divide by x. So here, when we divide by x minus 4, we can cancel them out, but we know that x cannot equal 4 because we just got rid of it. It would be a bad thing if x turned out to be 4. Now, how do we know that x can't equal 4? Because if we set x minus 4 equal to 0, we get x equals 4, and so basically we just divided by 0, which again is a bad thing. So now we have quadratics. So at this point, we can't cancel anything else out. We're going to go ahead and multiply everything out and set this equal to 0. So we're going to take x plus 4 times 4x plus 3. We get 4x squared plus 3x plus 16x gives us 19x. And then 4 times 3 gives us 12. Equals 41x minus 12. We want this equal to 0, so we're going to go ahead and subtract the 41x. We're going to add 12 to both sides. So we're going to subtract 41x. We're going to add the 12 to both sides. And we get 4x squared minus 22x plus 24 equals 0. We want to check if we can factor this, and there is a GCF. Each one of these terms can be divisible by 2. And because it's equal 0, whatever we do to one side, we do to the other. So we're going to divide both sides by 2. So we get 2x squared minus 11x plus 12 equals 0. Now to factor, there's a leading coefficient of 2, so we're going to take 2 times 12, we get 24. We ask ourselves what multiplies to give us 24 and adds to give us negative 11. We have two numbers, negative 8 and negative 3. So we're going to break this up to 2x squared minus 8x minus 3x plus 12. We group it. We take out the GCF of 2x. We have left over x minus 4. We take out the GCF of negative 3. We have left over x minus 4. And so our two factors are 2x minus 3 times the quantity x minus 4 equals 0. Okay, we solve each one. We set 2x minus 3 equal to 0 and x minus 4 equal to 0. When we do, we get two solutions. We get x equals 3 halves or x equals 4. Now we've got a little bit of a problem. When we plug in 4 into the original problem, we get 16 minus 16 is 0, and you can't divide by 0. Or even over here, we get 4 minus 4 equals 0, and it can't equal, we can't have the denominator equal 0. So x can't equal 4. This is called an extraneous or fake solution, which occasionally will happen when we're solving quadratics like this in proportions. So x equals 3 halves, we can plug 3 halves into the numerator and the denominator, or for everywhere there's an x, and then it ends up becoming a true statement. So in this case, we only have one answer of x equals 3 halves. And that's the only answer we'll write. We don't need to write the other one. All right, this concludes our video. At this time, you can go ahead and practice with the other practice problems. You've got the front and the back with practice problems, and then we'll check those next class.